Hello friends, myself Professor Rajendra Baburao Kharse, working as an head of electrical engineering department at NB Navle Sinhagar College of Engineering, Solapur. I am having a teaching experience of 9 years. I have completed BE Electrical from Government College of Engineering, Karad, and MTech from Indian Institute of Science, Bangalore. In the achievements, I have secured All India 7th rank in GATE examination with a percentile of 99.96. In my last video, we have discussed about the ABCD parameters, right? Basic definitions of ABCD parameters, and one simple example we have discussed, right? In today's lecture, we are going to discuss the numericals for the calculation of ABCD parameters, right? Some previous example, university examination numericals, right? So suppose we are having a question. This question has been asked in the exam December 2017 for 4 marks, right? December 2017 for university examination. Okay, obtain ABCD parameters for network shown in figure. Okay, so here we are having the given network. So this is a 2-port network, input port, this is a output port. Okay, loops, loops, right? So one thing is, it is difficult to apply to simplify the network by applying the KVL to the 3 loops, all the 3 loops, right? So first thing is, can we reduce this network from 3 loop to 2 loop? Yes. So we are having 1 ohm, 2 ohm and 3 ohm. These 3 are connected in delta, right? Can we convert that delta into its equivalent star connection, right? So yes, so if we convert this 1 ohm, 2 ohm and 2 ohm into its equivalent star connection, then it will become like this, right? So this is a star connection. Actually this was the original delta connection. Okay, now here we are having a 2 loop circuit. Okay, input port V1 I1, output port V2 I2 variables. Okay, now our task is to find the ABCD parameters, means ultimately we need to write the expression for V1 I1 in terms of V2 and minus I2, right? So simply, can we apply KVL to the loop 1? Yes, it is plus V1 minus 1 into I1 minus 2 by 5 into I1 minus 4 by 5 into I1 plus I2, right? So after rearranging the terms, we can write V1 is equal to 11 upon 5 into I1 plus 4 by 5 into I2. This is expression for V1 in terms of I1 I2, but we require expression for V1 in terms of V2 and minus I2, right? So we are not having problem with I2, but we need to replace this I1. Okay, so for that, can we apply KVL to the second loop? Yes, it is plus V2 minus 2 by 5 into I2 minus 4 by 5 into I1 plus I2. So it is V2 minus 2 by 5 I2 minus 4 by 5 into I1 plus I2, right? So after that, rearranging the terms, we can write V2 minus 6 by 5 into I2 minus 4 by 5 into I1, right? So here, can we write expression for I1 in terms of V2 and minus I2? Okay, so I1 is equal to 5 by 4 into V2 minus 3 by 2 into I2. Okay, so this is like I1 is equal to CV2 minus DI2. So can we write C is equal to 5 upon 4, right? Unit is mho, and D is equal to 3 by 2, and the unit is, it is a unitless. Now this is the expression for I1. Next, can we put this I1 in equation 1, right? So if we put this I1 in equation 1, we can get the expression for V1 in terms of V2 and minus I2. Okay, so put equation 2 in equation 1. So after putting the equation 2 in equation 1, we can write V1 is equal to this term. Okay, so after rearranging the terms, we can get the expression for V1 in terms of V2 and minus I2. Okay, V2 and minus I2. So here, by comparing this equation, right, with V1 is equal to A V2 minus B I2, right? So this is A is equal to 11 by 4, right? We need to compare it with minus I2. Okay, so that's why can we write it as a C, B is equal to minus 5 by 2, B is equal to minus 5 upon 2, right? So these are the final values of ABCD parameters, right? So please be careful. If in the equation, if here it is a plus, right, then if here it is a plus, then the when the parameter b is negative, value of parameter b is negative, right? So this is the one example, right, which have been asked in the Solapur University examination for 4 marks, right? Next, let us discuss one more example asked for 6 marks in the exam December 2016. Find transmission parameters for the two-port network shown in figure. Okay, so transmission parameters is nothing but the ABCD parameters, right? So in this example we are having 3 loops, 1, 2 and 3 loops. Okay, now one thing, can we reduce this network? Here we are not having, here we cannot reduce this network, right, by using the star delta or delta star, etc., right? So it is not possible to reduce this network. So we are going to simply simplify it by applying the KVL. So first apply KVL to the loop 1. Okay, so if we apply KVL to the loop 1, we will be getting plus V1 1 into I1 plus V1, sorry, it should be, it is better to replace this with 1. Okay, I am sorry, replace this with 1. Okay, replace this 10 with 1. Okay, so we can get, so it is plus V1, so here it will be 1, right? So it is plus V1 minus 1 into I1 minus 25 into I1 minus I3 is equal to 0, right? So we can write it as V1 is equal to 26 I1 minus 25 I3. This is your equation 1, right? Can we apply KVL to the second loop? Yes, it is 1.5 V1 minus 20 into I2 plus I3 plus 25 into I1 minus I3 is equal to 0, right? So after rearranging the terms, we can write expression for I3 in terms of V1, I2 and I1, right? V1, I2 and I1. Next, similarly, can we put this I3 in equation 1? Put I3 in equation 1. So it is expression for V1 in terms of, yes, I1, I2, V1 will be getting, right? Expression of V1 in terms of I1, I2. Okay, so this is considered as equation number 3. Next, apply KVL to the loop 3. If we apply KVL to the loop 3, yes, we can get it as plus V2 minus 20 into I2 plus I3 plus V2 minus 20 into I2 plus I3. So it is like this. So further we can write it as V2 minus 20 I2 minus 20 I3 is equal to 0, right? Put equation 2 in above expression, right? So if we put the equation second in this expression, we can get V2, right, V1, I1, I2 and V2 terms, right? Next, consider it as equation 4, right? And after this, what I have done, yes, here we are having the expression for V1 in terms of I1, I2 and V2, I1, I2 and V2, right? Similarly, we are having equation 3, that is expression for V1 in terms of I1 and I2. So if we compare equation 3 and equation 4, right? So at the left hand side we are having V1, right hand side I1, I2, I1, I2 and V2. So if we make the coefficient of V1 equal and if we add these two equations 3 and 4, right? So for that, what I have multiplied this equation 3 with 0.66, right? So by multiplying it with 0.66, then we are going to add that equation and equation 4. Okay, so here I have multiplied equation 3 with 0.66, so that after multiplying we will be having this equation, right? So consider it as equation 5, and again I have added equation 5 and equation 4, and after that, yes, we can get the expression for I1 in terms of V2 and minus I2, and again we are going to put this equation 6 in equation 3 for getting V1 in terms of V2 and minus I2, right? So V1 is equal to A V2, so A is equal to 0.259, B is equal to 5.506, C is equal to I1 is equal to C V2 minus D I2, so C is equal to 0.075 and D is equal to 675, right? So these are the values of ABCD parameters for this network. Okay, so this is about the ABCD parameters or the transmission parameters of the two-port network. Okay, these examples which have been asked in the Solapur University examination. Okay, Thank you. Thanks for watching.